Hello, this will be a demonstration of Proposition 30 from Book 7 of Euclid's Elements, which says that if a prime number measure the product of any two numbers, that same prime number also measures one of the two numbers. We're given two numbers, obviously A and B, and their product we're going to call C. So A times B makes C. Next, we're going to have the prime number D, and it's going to measure the number C. What we want to prove with this information is that the number D measures the number A or the number B. It doesn't have to be just one or the other. It can, in fact, be both. But it at least measures one of them. So we're just going to begin by assuming that the number D does not measure the number A. And what we want to prove from this is that the number D measures the number B instead. If it does not measure A, it measures B. So because the number D does not measure the number A, and the number D is prime, we can then say by Proposition 729 that the numbers A and D are prime to each other. Next, we're going to create a number. We're going to create the number E such that there are as many units in E as there are D's inside C. So remember, D measures C. So we can make a number E that is the number of times that D measures E. Now, because the number D measures the number C the same number of times that our unit measures the number E, by the definition of multiplication, definition 7.15, we can say that the number D times the number E makes the number C. But we were also given that the numbers A and B, when multiplied by each other, make the number C. So we have four numbers. If you take the product of them 2 by 2, they make the same number. So they're going to be equal to each other. That's simply common notion 1. So because A times B makes C and D times E also makes C, A times B is equal to D times E. And because this is the case, that D times E is equal to A times B, we can then change this into a statement about proportions by Proposition 719 and say that the number D is to the number A, just as the number B is to the number E. But remember, in step 2, we had proved that the numbers D and A are co-prime. They are prime to one another. And prime numbers are the least of those which have that ratio. That is Proposition 720 that tells us that. And we know that the least numbers of those which have the same ratios to other numbers measure those two other numbers the same number of times, the less, and the greater, the greater. So because the number D and the number A have the least ratio, are least that have the same ratio as B and E, we can then say in full that the number D measures the number B the same number of times that the number A measures the number E. But not all of that conclusion is important to us. What matters for us just right now is that the number D measures the number B at all, because that's what we wanted to prove. We wanted to prove that the number D measures the number B. Now, similarly, if the number D does not measure the number B, we can prove by a similar method that it measures the number A. So you see that if two numbers make up a product and a prime number measures that product, that prime number will measure one of the constituent numbers. So we're done with the proposition, therefore, etc., Q, E, D. An example of this proposition would be that 6 times 8 makes 48. 3 measures 48, right? So 3 is going to measure one of 6 or 8. And we see that it does. 3 measures 6. Now this can also go where this number, this prime number, actually measures both of the constituent numbers. So we can say that the number 2 measures the number 48. And we see that the number 2 measures not only 6, nor not only 8, but it measures both 6 and 8. So the number D doesn't just have to measure A and not measure B, or just measure B and not measure A. It can actually measure both of them at the same time. That's all I've got to say about this proposition, so I'll end the video here and move on to Proposition 731.